Okay, so I'm going to show you how to do a nearest neighbor stuff in Excel. I mean, this is very specific for my lab, but you'll learn a few things in here that might be transferable to other things. All right. So let's say you have measures of the distances between 21 different trees, right? These are the nearest neighbor trees. So here's tree 1, tree 2, the distance between them is 3.37 meters. Okay, so we have 21 trees total, 20 distances. All right, let's kind of clean this up a little. Let's make it a little simpler for us, so that way we don't get confused with this X in here. So we have 20 distances. Now, for what I'm going to do here, it's important that we keep them in the same order. You don't have to have them in the same order for other things, but for this particular exercise, they have to be in the same order, because we're going to look at the effect of what is the effect of adding additional trees to our sample. Okay, so what we're going to be doing is we're going to be using this equation. D is equal to 1 divided by 4r squared, and put the little caret there. That means squared. So that's the equation that we're going by here, for where r is going to be the mean distance of all distances, and d is going to be the density, in this case, of our trees. Okay, so we could just calculate the mean of all of these and get our d, but for this particular exercise we want to say, what is the effect of going from this would be 2 trees, right? This is one distance. What's the effect of adding a 3rd tree, or a 4th tree, or a 5th tree, 6th tree, 7th tree? How do those data affect my calculations? Does it make my D better or worse? These are just random numbers, so don't expect any real patterns to show up. But let's illustrate sort of the calculations that you would do. So what we need to do is we need to get the average, right? And we need to get what you would call a running mean, or running average. Okay, let me make that look a little pretty. We need to get the running mean. So we need to say, what is the mean if we just looking at this one? If we only had that one data point, that's not going to tell us much. But what if we had these 4 data points? Versus if we've had that, what is that, 10, those 10 data points. How does that change our results? So what we need to do is we need to get the average of these 2, then we need to get the average of these 3, then we need to get the average of these 4, and of these 5. Okay, so to calculate average, we use the function average equals average. Oh, I gotta click here and type. Why is it not coming up? I don't know. I'll just click up there. Equals average, and then parentheses, and then the numbers that we want. Getting an average of one thing is pretty nonsensical. Let's just do it anyway. Equals the average of that. Wow, I'm surprised. Okay. Now this one we want it to be equal to the average of these 2. Okay, see how that is D2 to D3. And this one we want it to be equal to the average of these 3. Okay, now rather than type each equation over and over and over again, that would be kind of ridiculous, and that kind of defeats the purpose of Excel. So here's what we can do. I'm going to show you on this cell right here. I have the average of D2. Let's say we want the average of D2 to D2. So it's going to calculate the average from cell D2 all the way to cell D2, which is not going anywhere. Now if I copy this and then I paste it here, what's going to happen? It's going to shift the equation, so it's the average of D3 over D3. So I click here, and this kind of puts a outline around the parts of this equation, so D3 to D3. And if I had to copy it here, it's going to shift it. So now, because we've gone down a cell, it goes from D3 to D4. If I were to go to the right, if I copy and paste it over here, because we changed the column but not the row, we've gone from D4 to E4. Okay, so Excel will change the locations, change the equations as you change the, if you're copying and pasting, not cutting, but copying and pasting, it will adjust the equation based on how you've moved up or down, right or left. Okay. All right, but here's what we can do. What we want is we want to keep this one always in our equation. We want to basically anchor the average here. So we calculate the average of those 2 and those 3 and those 4 and those 5. So here's how we can anchor it with a dollar sign. If we put a dollar sign in front of this 2, see right up here, if a dollar sign in front of that 2 is not going to change. That 2 is always going to be there. If you put a dollar sign in front of the D will never change. So watch, I copy and I'll paste it here. Let's look at this equation. So this equation is D2 to D2. This equation is now D2, even though I copied and pasted it. That part hasn't changed. But the other part that didn't have the dollar signs has changed. So now it's D2 to D3. And if I copy and paste it here, now it's going to be D2 to D4. So what I can do is I can just copy that, paste in that whole section, and if I click down here, get rid of that. I hate that. Excel's such a pain about that stuff. If I click here, I have D2, because that's not changing anywhere, all the way to D10. And this one is going to have D2 to D21. Alright, so see, you can use the dollar signs to lock a cell in. And if I were to go to the right, it would be D2 to E7. Alright, so D2 was locked in, and the second one changed from D7 to E7. So from D7 to E7, so now it's getting the average of all of those. Okay, cool. And if I were to have gotten rid of this dollar sign in front of the D, and I copy it over here, what's my equation going to change to? The 2 is going to stay the same, but the D7, that'll change, but it's the same row, so the 7 will remain. The D will become an F, and this will become an F. So it's going to calculate the average of F2 to F7. Sorry, E. I'm putting in column F. D changes to E. E comes after D in the alphabet. Duh. Alright, does that kind of make sense? Alright, so I'm just going to copy this, paste it throughout, boom. So that's our running mean. It's always good to label, so let's label with an, I hate when it does that to me. Put a little space there. Still going to do it? No. That's our running mean, or our R. Okay? So I'm going to do this equation piece by piece so you can see how it's kind of put together. Although me, I would just stick the equation in one cell. I'll show you how I do that. Alright, so now let's calculate R squared. R caret 2. And calculating a square is very easy. It's equal to this value, and we put the caret, and we put the exponent 2, which is R squared. Alright, I'm going to paste that in there. And let's calculate 4R squared. It's simply a matter of equals 4 times the asterisk, that value, and that is going to be our 4R squared. And then let's calculate D. And what is D? D is, per our equation over here, 1 over 4R squared. So it's going to be equal to 1 divided by that. Copy, paste it throughout. That's our D. Right? That's the thing that we're most interested in. Now, it's perfectly fine to do it this way, and especially if you're just learning with Excel where you have very complicated equations, it's good to break them up into pieces in case you make a mistake somewhere. It'll be easier to see where the mistake was made. This is a relatively simple equation. So what I would have done is I would have done the following. Let's just copy this and paste it here. I would have just joined it all into one equation. Equals 1 divided by, then I need to put in some parentheses, 4 times R, which is, I put this in parentheses. It's always good to use parentheses as far as I can tell. It breaks things up. The average of, and remember what the running average, so let's click on that twice. And we don't want J2 to change. So I'm going to do that. This is a tip: if you hit the F4, if you're selected on a cell and you press the F4, the function 4 button, it'll stick $2 in there. And then we want to take the square of that, and then we got to close off our parentheses, so that parenthesis here will match with that one there. We put one more, that one will match with that one. See how they get colorful like that? Black, they get black and bold. This one is red and bold, or maroon, I don't know what that is. And then that's it. Boom. Let's paste it here, and these numbers are all the same. Right? That's how I would do it. It's not necessarily better. Alright, so now what are we concerned with? The question is, or this is just for this particular lab, but we want to plot as D changes, how D changes as we add more trees. So for this one, it's very, very simple. Let's just do this. We select these. Don't select X and Y, because this value here is no longer important. We just select this. We're going to insert, and in this case, we want to do a line. And let's do a line with little markers, so we can see the individual points. Alright, and then this is basically, these are basically our results. Alright, so this represents the number of additional trees, and this is our value D. Obviously you don't want that garbage up there. This is not adequate, right? You have to make this look like a good figure. You know, you gotta fix your axes, put axis titles, get rid of these stupid lines Excel likes to stick in there. Alright, but this is the basics of where you want to start, and then you want to make it look like a nice scientific figure. Now, this is one of the few cases where you're going to want to include all of your data. And why is that? It's not because we are looking at our value of D for any particular area. It's because we're looking at how D changes as we add more trees. So it's really what we're analyzing is D, and it's the change in D over time that is important. Alright, so this is one of the few cases in where you're going to want to report your basically your raw data. You're not going to want to report these. Alright, don't care about these, but you're going to want to show this. Okay, I think that's it. Have fun.